In this video you will learn everything that you need to know about Node.js event loop. And if you're a Node developer or you want to dive deeper into Node.js, it makes a lot of sense to learn this because this is the core functionality of Node.js and you must understand how it works under the hood. This video is brought to you by Beeceptor. And one of the most popular products of Beeceptor is Mock API, which allows us to create a fake API in a matter of seconds. We just need to paste here our JSON and select the URL that we want to create. Here the response is 200 and we're clicking Create Mock Server. Now we can use this URL with /articles to get access to our mocked list of articles. Additionally, we can configure different rules, for example when we need to simulate a delay. Now we will get our articles only after 2 seconds. To try it yourself, check the link in the description box below. With that being said, let's jump into the video. And actually there is an amazing blog post written about Node.js event loop. This is why in this video I want to go through all points in this blog post because it is quite complex, so you can understand all concepts of event loop. Let's start from the beginning. First of all, we must remember that JavaScript is a synchronous language, so it executes code line by line. If we have here 2 functions a and b with 2 console logs and we just call them in 2 separate lines, first of all console log a will be executed and then console log b. Another important point is that JavaScript is blocking. What does it mean? Until our previous line is executed, it won't continue execution of our code. Which actually means if here function a takes extremely long period of time, then line b won't be executed. In the browser, it leads to the problem that your whole page will be completely frozen and irresponsible because no user interactions will happen while your process is blocked. The next point is JavaScript is single-threaded, which actually means we have just a single thread and all our tasks are completed there. We don't have lots of threads like in other languages, so we can't do several tasks in parallel. And typically in JavaScript our thread is called main thread. Now with this knowledge we can understand why JavaScript has problems with the synchronous code, because by default it is not possible to write any asynchronous code. We can't do any long task because it will block JavaScript execution. So this is exactly how JavaScript works both on the client and on the server. But in Node.js we have a huge difference between client code and server code. On the server it is possible to access C++, for example. So inside Node.js runtime we have external dependencies like v8 or libuv or crypto, and we also have C++ features which allows us to access resources of our system as well as HTTP. And on top of C++ we have a JavaScript library which allows us to write code in the way how we know it. And the most important open source library for Node.js is called libuv because this is exactly what we are using for all asynchronous operations inside Node.js. So this is how it typically looks inside Node runtime. We have memory heap, call stack and libuv. As I already said, libuv is for asynchronous tasks. We create all our variables and functions inside memory heap, and in call stack, one by one, our code is being executed. Let's look here on the synchronous variant. We have here 3 console logs, nothing else, and every single line, one by one, is being placed inside call stack. It is executed, we see our console log, and then it is removed from the call stack. libuv is not working here because we don't have any asynchronous code. But here it is different. We have a console log and then we have a read file operation, which is an asynchronous code with the callback console log second and then console log third. How does it work in this case? Obviously we have a console log which just goes to call stack and we see it in the console. Secondly, we have this fs read file. It goes directly to the call stack, and as this is an asynchronous operation, it is being moved to libuv, and as we can't do anything else with it, it is removed from the call stack. Now we are going to the next line, console log third, it goes to call stack, and we see it on the screen. So our code looked like a list of synchronous operations, and the only difference is that now we have some asynchronous code inside libuv. Now here are some questions so you understand that we need to dive deeper inside libuv internals. For example, when a synchronous task is being finished inside libuv, at which point Node will run a callback of this task? Does Node wait for call stack to be empty before running a callback function? Or does it interrupt our flow and simply executes a callback? What about asynchronous methods like setTimeout or setInterval? Because we know that they also delay execution of our functions. And if two different tasks, setTimeout or readFile, complete at the same time, which callback will be executed first? These are all completely valid questions. Everything that is being done inside libuv is called an event loop. This is just a C program which manages execution synchronous and asynchronous code in Node.js. And event loop starts directly when you start your Node application and runs continuously until you stop your Node application. And here is a diagram that must answer all our questions about event loop and libuv. So we have an event loop. This is why it's a circle. It goes in the loop indefinitely together with our Node application. And we have here 4 different pillars. It is setTimeout and setInterval. This is a part of the timer queue. Then we have IO queue. These are file operations. Then we have a check queue. Inside it we have just setImmediate function, which is specific to Node.js. And the last one here is close queue with close handlers. And additionally to that, in the middle, we have a microtask queue. First of all, we have a function nextTick, which we can call like process.nextTick, and after this, all our promises. And you need to remember that these 4 pillars, timer, IO queue, check queue, and close queue, are the part of libuv library. Microtask queue is a part of Node.js runtime and not the library itself. Now you must understand the order how all this stuff is running. At the very beginning, the microtask queue is being executed. First of all, nextTick, then promises, if we have any to execute. After this, we are going to timer queue, and we're executing callbacks for our setTimeouts and setIntervals. After this again, we're going to microtask queue, we're doing nextTick promise again, and we're going to the next section, which is IO queue. Inside IO queue, we're executing IO callbacks, and again we're going to our microtask queue. We execute nextTick promise, and we're getting to our check queue. Here we're calling setImmediate callbacks, again microtask queue, and after this we're going to close queue, we're calling our close handler callbacks, and then again microtask queue. And then this loop goes again and again until we close our application. And just to make it clear, when I'm saying IO queue and file operations, it also includes working with HTTP. Now let's look on the answers to these questions that we saw previously, because this information is also extremely important. First of all, when an asynchronous task completes in libuv, at which point Node decides to run an associated callback. And callback functions are only being executed on the empty call stack, which actually means if we have some code inside our call stack, this function won't be called yet. Secondly, does Node wait for the call stack to be empty before running a callback function, or does it interrupt the normal flow? The normal flow is never interrupted, and our callback will be executed only when our call stack is empty. What about other methods like setTimeout or setInterval? Now we know setTimeout and setInterval are being executed at the beginning after our microtasks. If we got our setTimeout together with some IO operation at the same time, first will be executed our setTimeout callback and only then the callback of IO task, because the first priority goes to our timers and second priority goes to our IO operations. If Node.js is still complex for you and you would like to build a full project which uses client and server logic, make sure to check this video also, where I covered exactly that.